And good afternoon, ladies and gentlemen. It is still Cinco de Mayo, 5th of May, 2017. I want to talk about the where Fuller gets into sphericity. Like we've been doing a lot with modules. Bob Gray put this excellent version of synergetics online shortly after Fuller died. Actually, maybe it was in the 90s because, of course, we didn't have the World Wide Web in the 70s. Synergetics in 2 volumes. This came out in, let me look it up here, I believe in 79. Okay, this one came out in, 82. Maybe this is not the hardback. First Macmillan paperback edition. So there was a hardcover, I think, 75. So there was a hardcover of this in 75, and this still is the hardcover. It talks about Ed Applewhite on the dust cover as well. And this is copyright 79, first printing. So this is a first printing. I probably bought it. I don't know where I got this one, but these come and go in my collection. I have a pretty good collection of Bucky books, but also I'm borrowing a collection of Wittgenstein books. I have maybe 40 to 50 Wittgenstein-related titles right now. They're on loan, however. It's not like, so I'm taking advantage, I hope, and reading as much as I can. Wittgenstein is one of my heroes from Princeton days. I feel like I got really a lot out of reading his work. And then Fuller later. Kind of out of Princeton, I was living in Jersey City and tracking the career of Werner Erhard. I had taken the EST training, and so I was getting the graduate review, and when Fuller and Erhard appeared in Madison Square Garden, I took notice. I wasn't there. I didn't make it to that, but I was paying attention. So from there forward, I started studying synergetics. And coming from a philosophy background, like fresh out of Princeton, you can see where I was curious to decide, is this philosophy or not? And I got into, much later, a conversation with Dr. Suber at Earlham College as to whether synergetics was really philosophy or not. By then, I'd already developed my website, so there was something to talk about in terms of whether my website should be listed at his index of philosophy sites. And after a while, yes, it was. He agreed that this was philosophy. But where does it get spherical? That's the question. Because in Synergetics 101, I spent a lot of time with these modules, as I'm showing you here. The sites, the mites, the cat and Kate. I may get them reversed. The kit. It's not like everyone uses this terminology today in the early 21st century, 2017. Hardly anyone's using any of this terminology, but it makes a lot of primitive sense. Like, this is kind of the thing you would look into if you were doing basic geometry kind of on a desert island. Like, let's dissect the tetrahedron into modules and the octahedron. Like, he does very kind of normal things, I would say. I don't know, it's the kind of thing you would do if you were on a desert island and just had infinite time to think about this stuff. Now, a lot of people don't, and that's part of the whole deal. It's like, how do you get a job where it's your job to figure out all these great circle angles? I mean, are you a geographer? Are you working for National Geographic? I mean, the geodesic dome isn't even invented yet at this point. So what Fuller does is he takes these polyhedra of the concentric hierarchy that we've been talking about, and he starts to spin them around their face centers. You've got these axes that you can jab in, and out of that get these great circle spin axes. Jab them through great circles, jab them through opposite faces, opposite edges, mid edges, and opposite corners. There's 12 corners, so you have 6 poles there, 6 axes, 10 for the 20 faces, and 15 for the 30 edges, right? So you add those up, and you get 31 great circles, which then cross each other. As you spin all these things, you get a network of crisscrossing great circles. And what a lot of synergetics is when we get into the spherical stuff is about, let's go to this one. It's about spinning the cuboctahedron and the icosahedron and then overlapping their 2 great circle networks and then figuring out all the angles. And they're redundant. Like once you do this spin pattern, of course, there's all these mirror images. You don't really need to know all the angles, but of one, what we'll call a lowest common denominator triangle. And this is one of the 48 lowest common denominator triangles for the cuboctahedron or vector equilibrium. Once you spin and get the sphere with this mapping, then you've got enough information to go off to your computer and start figuring out all the chords, all the arcs, and pretty soon, before you know it, you're tabulating large amounts of information. And in Synergetics, is it volume 2, towards the back, you start to get all these spherical angles, planar face angles. It goes on for some pages where Fuller is tabulating all this information. And you might think, any half-decent computer program, you could do this kind of thing, and why do you put this in your philosophy book? Well, no one else is really doing it, and he's eager to do what we would call today basic research, and he's self-funding pretty much. Like the universities hire him, and he does his job teaching, and so, how Fuller made a living is pretty interesting. We could talk about that, but the point is, he's really interested in doing some very basic numerical research. Geometry meets computational geometry, we should call it. And, we're talking early 1900s, mid-1900s. He's already interested in this stuff quite a long time before Synergetics, the book, is printed. So you should take away from this segment that the geodesic dome, for which Fuller later became famous, really came out of studies involving the sphere and subdividing the sphere based on spinning these polyhedra of the concentric hierarchy. That would be a better way to think of where synergetics comes from than if it just started right away with the geodesic dome, which it really didn't, right? So here you have a superimposed great circles, 48 great circles of the cuboctahedron. Now, where does the 25 primary great circles come? That's from the 12 opposite edges, because there's 24 edges total. So 12 plus opposite faces, you've got 14, so that's 7. So 6 plus 7, and then with the faces we just did, so let's see, vertex is 6. So 12 plus 7 plus 6 is 25, right? And that's the great circles you see. After you spin all those axes, you get these intersecting great circles. And then there are what he calls secondary great circles, which, without going into a lot more detail, he then superimposes on the icosahedron so that you've got the 72 and the 25 both together on one sphere. And then you've got to get the LCD, or lowest common denominator triangles, based on all those. So he keeps going through the same themes of spinning. Now remember, the cuboctahedron and where's my vector equilibrium here? The cuboctahedron and icosahedron are related through what we call the Jitterbug Transformation. And I should have my little stick model here where I can show you what that is again. But look in Synergetics 101 and you'll see what that is. The icosahedron is this shape, and the cube octahedron, as you know, is 14 faces, 8 of them triangles, 6 of them squares. So that's where you get the sphericity. Now, the discovery of Buckminster fullerene, the carbon cage molecule, was 60 carbon atoms organized in a soccer ball-like pattern. That didn't come in Fuller's lifetime. He was around to see how the virus ended up being a geodesic sphere, or at least having the numbers that he'd predicted, some of them. 10f squared plus 2, I have a video about that. So he was pretty excited and thought he might become famous in his own lifetime with the virus story. This is kind of my Russian dolls going here. I got another ball inside that one. And now I'm going to put the cranium back together again. It's like I got the brain out. Now let's put it back together. This is just a distraction of a cool kind while I think about how Fuller wants us to associate the great circles and the geodesics with the generalized principles, which was the subject of my previous video. Somehow the way that special case compression world is contained and made to make sense is because of the embracing generalized principles that keep everything coherent and sensible, you could say. Sense and nonsense is a fine line sometimes between those two. So let me just leave you there with that thought, and remember, synergetics is both a spherical networky kind of thing and more of a chunky block kind of thing. And it's a mistake to get too hooked on either one or the other of those two aspects. All right, talk to you soon.